Bismillahirrahmanirrahim. In this session, we will discuss test yourself from page 67 from the topic of section 1.7, that is energy, work and power from Hodder's IGCSE and O level physics book. And in the previous session, we have discussed all these problems, and in this session, we will discuss from page 67. Test yourself. Question number 6. How much work is done when a mass of 3 kg with gravity is 9.8 newtons per kilogram is lifted vertically upward, vertically through a 6 meter height? So we have to ask. We have been asked to find the work done, and the inner mass is given as 3 kg. G is 9.8 newtons per kilogram, and the height is 6 meter. And work done is equal to mgh, that is 3 kilogram 9.8 newtons per kilogram into 6 meter, and this kilogram will cancel with this one, and Newton in meter is joules. So we multiply all these and we have this 136.4 joules. Question number 7. A hiker climbs a hill 300 meters high. If she has a mass of 51 kg, calculate the work she does in lifting her body to the top of the hill. So we have to find the work done. Height is 300 meters and the mass is 51 kg. So mass of work done is equal to mg is equal to 51 kilogram, 9.8 newtons per kilogram. Yes, 300 meters, and we multiply R, and we have this much energy required, or this much work done required to climb this much height. The problem number 8. An electric motor does 80 joules of work in lifting a box vertically upward through 5 meters. Calculate the weight of the box. So we have to find the weight. Work done is 80 joules, height is 5 meters. Work done is equal to weight into height, and weight is equal to work done upon height. 80 joules 5 meters, that is 6 newton. Now put this into practice. Page 67. A robot is used to lift a load. If the energy input of the robot is 8000 joules, in the time it takes to lift a load of 500 newtons through 12 meters, calculate the efficiency of the robot. So the input energy is equal to 8000, weight of the load is 500 newtons, height is 12 meters. So this is the output energy, which is weight into height. So this is 6000 joules. So weight into height is, this is the output energy required to lift this weight. So this input energy, as a result, it loads this much at this height. So the output energy divided by input energy gives the efficiency multiplied by 100 to give in percentage. So this is 75%. If the energy input to an electric motor is 560 joules per second and 170 joules per second is transferred to the thermal energy when in use, calculate its efficiency. So this is input energy, this is loss. So output energy is the difference of these two. So input energy is this. So energy rate is a power. So energy loss or power loss is 170 joules per second. Output energy per second, that is output power, which is 390 joules per second. So efficiency is output upon input, and it is 69.6%. So this is the output energy per second, and input energy per second is output power, input power, and this is the efficiency. Test yourself based from page 73. List 6 properties which you think that the ideal energy source should have for generating electricity in a power station. So every large-scale electricity generation should have a clean, convenient, fairly cheap or economical supply, low environmental impact, having low pollution emission, with high reliability, high availability. So these are the 6 factors that is very important for any ideal energy source. List 6 social everyday benefit for electricity generation is, so that is lighting, heating, cooling, refrigeration, operating appliances, computer, electronics, machineries, and public transportation system, and many others. So these are some of the major benefits of electricity generation. Some other details are also here. Draw up 2 lists of suggestions for saving energy in the home and globally. So it economical, it will low energy bill will be received, and it will create less pollution to the environment, and the resources will be conserved for the next generation. So if we consume less resources, so more resources will be available in the next generation. This is the important point. Efficiencies of energy transfers can be energy output divided by energy input, or work done on load and work done by the effort. Output work done, input work done. And so in this way we can get the efficiency. Output divided by input into multiply by 100. Some of the major devices having efficiencies. The filament have a very low, electric motor have very high efficiencies. And now question number 11, calculate the efficiency of a compact fluorescent light of a power of input 20 joules per second gives an output of 9 joules per second. So the input power is 20 joules per second, output power is 9 joules per second, so the efficiency is 45%. 9 joules or 20 joules. And now test yourself, page 74. A boy whose weight is 600 Newton runs up a flight of stairs 10 meters high in 12 seconds. What is its average power? So this is work weight 600 newtons, height is 10 meters, time is 12 seconds, average power is equal to weight height divided by time. 600 newtons into 10 meter divided by 12 seconds is 500 watts. That is 500 joules per second, or that is watt. Calculate the power of the lamp that transfer 2400 joules to the thermal and light energy in 1 minute. This is the energy 2400 joules, and 1 minute is 60 seconds, so divide by this 60 seconds gives 40 watt. An escalator carries 60 people of average mass 70 kg to a height of 5 meter in 1 minute. Calculate the power needed to do this. So the power needed, the numbers of people are there, 60, 70 is the mass of average people. Total mass is the number of people and the average mass, so that is 60 into 70 is 4200 kg, and height is 5 meter, and time it takes 1 minute 60 seconds, so the energy is required is 4200 mass. This is G and this is H is 5 meter, so this is the energy, and divide by 60 seconds is 3430 watt. This is the required output power. These escalators we can observe in a large mall, shopping malls or shopping centers. So this is very, very important. In the next session we'll discuss exam style questions.